Now we're going to actually put a closure into our function, and this is where things start to get fun. The best way to start is to usually to make a struct, because it's fun to give functionality to your struct, and with a closure you can take in self and do a bunch of stuff. And so let's make a classic book struct. We've done this a lot. We have this book with a name and a year, and then we're going to implement it. And you have a classic method is just like print name, and then we've done lots and lots of these before. So just say like the book's name is, and then you do that, and then you say self.name, and that's a fine method. It'll print the name. But let's say we want a closure. We're imagining that somebody's going to use this book struct, and we'd like to give them more possibilities to make changes to it, and also especially later on when you start having like a public and private. Like most fields by default are private, and later on when you have like lots of files for your Rust code, you have to say pub if you want outside people to have access to it, and if not, they won't be able to directly say like book.name, book.year, and they can only do things through these methods. And so we would like to make these fields private for whatever reason. We don't want them fooling around too much, but we would like them to be able to make some changes with a closure. And so we'll do that. We'll call it change, and this is going to be generic, because we are a closure has one of three traits. So in generics you talk about the traits, and so we're going to give it a mute self, and then that is the closure. But the compiler doesn't know it's a closure yet, because right now it's just some generic f. There's an f in there that is some generic type called f. And so you could say, closure, you could do this, and you could call this a thingy, and closure, you don't have to call it f, but whenever you see this in code all the time, FF, and it's good to get used to it, even if it looks kind of funny at the time with all these like capital and lowercase f's, but it usually is a hint that there is a closure. So we will go with fn. We'll just choose we could also do fn mute, but let's just go with fn, because fn can do anything, and it's nice to start with the most a closure that will probably generate the fewest errors. And so we will so it takes a mute self. That's what we're going to give it. So this will be a closure that takes in a mute self. And we can also, by the way, say mute book, and that might be a bit clearer right now, so we can see it's taking in a mute book. So it's going to do something to it, and then because it's a closure, you call it inside the function. So you have an f, and that's you see this a lot, just f and nothing, or in this case f and self, because we are passing in self. So this is actually that is what it looks like, and you can see the compiler is not having any problems with it. So just to look at it one more time. And also this where you can also do, f is a fn mute book, but this tends to be kind of long. So it's for closures, you see this people using where a lot, because sometimes a closure is a function, so it could return an i32, it could return an arc with a mutex inside it with vec of string or super long, and you don't want to put that inside here. It gets really long, so you see this where a lot. And so now we have this closure, or this method with a closure inside it called change. So let's make our book. So my book equals book, And once we, let's see, give it a name, I will call it the wheel of time toString. Don't forget that. And the year, I think it was published in 1991 or something, 1992 maybe. And now okay, let's change it. So here's our closure. And so now we're not making it, we're actually using a closure, and we're very used to this. So what are we going to do? myBook.change. And so this is bringing in self. And you know, when we bring something into a closure, we give it a name. So like we've given it given small names, or sometimes a closure, you know, brings in two things, but here it's one, so we can just call it let's call it cool book, and we will say cool book. And now we have mutable access to this book, so we can just do whatever we want. It's so we can say cool book plus name equals the Hollow Hills. So we're going to change that and to string, and then we're going to say if cool book dot name dot year modulo true, then we can say print it was, it's an odd, it's an even number else. So we're doing, you know, all sorts of stuff now. It's an odd number. And then, you know what, we still have a mutable reference, so coolbook.year equals 5. Oh, and let's give it, let's do derive debug so we can see it, we can print it out. And then print line like that, and my book. So hopefully I did everything right. And that's right, equals 0. Expected a bool. And there you go. So it's an odd number, so that's good. And then we print it out, and now it says it's the Hollow Hills, and the year is 5. So we have successfully used a closure to do all sorts of cool stuff. And the key to this is the closures took me so long to figure out, and they still take a lot of concentration. But look for these Fs. Choose the kind of access you want to give it. Start with Fn. That's easiest, and then just write an F, and then think, you know, what do you want the closure to take in? And that's why this part is usually pretty simple. Like what took me a while was I was treating it like regular functions, and I was bringing in like input 1 and, you know, string, and then I would have to throw those into the closure too. When closures are usually just about super simply just calling it on something, and leaving the rest of it to the user who will then be, you know, coming up with whatever they want to do based on the access you give, which is based on the trait, which is fn mute or fn once.